All right, sixth graders, lesson 64, quadrilaterals. If you remember, we learned that quadrilaterals are polygons, so they're shapes with four sides, and that's it. So there are lots of different quadrilaterals that we see here. Some of them maybe we know by name. And there we go. These are all quadrilaterals because they're closed. All of the sides touch. An open one would look something like that. All of the lines are straight. We don't have a curvy line that brings us back. So a quadrilateral just needs to be a four-sided figure. Now in the quadrilaterals, we want to point a few things out here. Parallel sides. Remember, two lines that never cross are parallel. And so we take a look at some of these and we see this side is parallel to this side. This side is parallel to this side. Here in this one we see that the top is parallel with the bottom, but that's it. The two opposite sides are not. We're here in our third figure. Again, we see this side is parallel to this side, and this side is parallel to this side. We use those lines there just to show this one and this one are a pair, and this one and this one are a pair. Down here, and we see this is parallel to this side, and this side is parallel to this side. In our next one, you see the top is parallel with the bottom, the right is parallel with the left. Over here, I'm not going to be, they look like they're parallel. They're not the best drawn, but they're opposite. And in this figure, I did not intend, and maybe it looks like they're parallel, but I did not intend for opposite sides to be parallel there. And obviously in this one, I don't see any parallel sides. So let's name some of these. If they have no parallel sides, we call that a trapezium. This we actually call a kite over here because it looks like a kite. This side matches this side in length, and this side matches this side in length. Alright, if we go back to the top here, opposite sides are parallel, and in this one I would say the corners are all square. In this one I don't see square corners. In this one the corners are square. Not here. They have angles, not here and not here. So that helps us also then to continue on in our naming process. This therefore would be a rectangle. It's got opposite sides are parallel and it has square corners. This is a trapezoid. Kind of sounds like trapezium down here, but a trapezoid has only one set of parallel sides. So another way to draw a trapezoid would also be like this, because only the top and the bottom are parallel, not the left and right side. Alright, this figure over here, square, all sides are equal in length and they make right corners. Over here, a rhombus, all sides are equal in length, however the corners are not square. And here we have a parallelogram. Opposite sides are parallel, but the corners are not square corners. So we see all the types of quadrilaterals that we will be studying here. So let's go on to Example 1 says, is the following statement true or false? All parallelograms are rectangles. Well, we'd have to say no. And the reason I can say is all parallelograms are rectangles. No, because this is a parallelogram, but it's a rhombus. This is a parallelogram, but it's a square. So those are examples of two shapes that are parallelograms, but are not rectangles. Example 2 says, draw a pair of parallel lines. Alright. Then draw another pair of parallel lines. These lines should intersect, which means they have to go through the first pair, but not be perpendicular. So I can't make them straight up and down and make 90-degree angles. What is the name for the quadrilateral that is formed by the pair of intersecting lines? Well, in my case, I could almost say there are two. It's obviously a parallelogram because opposite sides are parallel. This side is parallel. This side, the top is parallel with the bottom. But because it looks like all of the lengths of the sides are the same distance, I could also call it a rhombus. So in this case, the figure could be both a parallelogram for sure and also a rhombus because it looks like all the lengths of the sides are equal. Alright, I want to show one here, how everything is related. I've got quadrilaterals to learn about. They are four-sided figures. In the quadrilaterals, we can divide them up into three groups. We have trapeziums, where they don't have any parallel sides. We can have trapezoids, we only have one pair of parallel sides, and then we have the parallelograms, two pairs of parallel sides. Now the parallelograms can be split into two groups here. I can say some parallelograms are a rectangle because they have two pairs of parallel sides, but their corners are square. Or you could say the rhombus. All sides are equal length, not square corners. However, opposite sides are parallel. And then both of those come back together again if you combine the properties of the rectangle and the rhombus, so that with the rhombus we take all four equal sides. Rectangle we take square corners, we have the square. Opposite sides are parallel and we have a square corner. So again, this is just kind of a map showing how all the different quadrilaterals are related. Trapeziums and trapezoids are kind of on their own. It's the parallelogram family under which you see squares, rectangles, and rhombuses. Alright, that's it. You can get started on your lesson practice today.